So please move from here and exit, Dr. Girish, where is Dr. Girish? Exit number, exit. No schools are going out, only schools are going out. All students, be here, you have the reports, you need to fill the reports of yourself also. Only schools are allowed to move from here. Call your driver, the buses will come from here. In case surprise gathering of 2000, it will happen in such a beautiful way. Thanks to all the team from the coaching, Dr. Girish, Shalini, and everyone. Now team 39, guys, all the stewards, 40 stewards can come here. School number 39, along with the teachers. While going out, teachers are requested to collect their transport. The people are sitting outside from the guidance. Back to the KV, collect your lunch boxes, and then get into their buses. And our communication will continue. I promise you, as the Honorable Minister has told, so we try to follow that milestone with the other number. Can I request team number 38? Thank you, ma'am. See you again. We'll be in touch. Team number 38. With children, with the teachers, with the stewards, with the witness, with everyone. Media is free to come, have interactions with the students here. But students are not requested to move from their places. Please. Thanks a lot. Team number 37. Team number 37, along with the teachers. All the teachers are requested to drop me an SMS or email of their safe return to the schools. All the teachers, after reaching to their respective schools, are requested to drop me an SMS or an email of their safe return to the school. Team number 36. Thank you so much. Team 36. So all your inspirations, all your motivations, everything today, let's see 6 along with the teachers. Teachers are requested to collect their transport while going out. 36. Our communication will continue. All your queries will be solved. Don't worry. 35. Team number 35, along with the teachers. Great. Team 35. Thank you. Thank you so much. Great. Wonderful one. Thank you. Team 34. Dear children, great work. Wonderful. Great work. Is going to be recorded today. Thank you. Three stewards are left out to submit their reports. I request the stewards to please submit the reports to the witness. Team 34, great boys, great girls. You are the proud children of our country. Steward number 3, please submit the reports. Thank you, ma'am. Thank you so much. 33, great boys. Please, thank you. And you safe journey back to the school. All teachers are going to send me the SMS or email of safety return to the school. Dear children, please be seated for a few more minutes. I will certainly call you. You are really marvelous children. You are really marvelous. 33. The rest of the children, please for a few more minutes, cooperate. 33 is it? Thank you, children. 32. Great work. Wonderful. Again, I request all the teachers, students, you are supposed to collect your lunch boxes from KV. Teachers, please send us the SMS or emails of your safety return. 31. Yes, congratulations dear. Let us select 31. Great. And if at all any success comes, Madam, you will send me the safety return of your school. Now team number 30. Please collect your lunch boxes from KV. Teachers, you collect your transport. Thirty left.
Really good experience.
29.
So much of fun.
Hey, you let us see who made it. Thank you. Please proceed.
मेरे को भी लगी थी पर वो नहीं है मेरे को भी लगी थी वो नहीं है
Children, please be on your tables for a few more minutes. You have shown a beautiful structure of yourself. how meticulous, how beautiful you are. Please. 28.
और भैया
अब कुछ नहीं जाए तो क्या जाने पास ही जाने भीड़ हो
व्हाट्सअप कर देना
Pay attention. I request all the stewards to please be seated in your seats. Teachers, please monitor the students are seated. I request all the students to please remain silent as we're going to begin the event.
My dear children, we are going to create a record. Are you ready? Yes. Dear respected witnesses, stewards, teachers and my dear students, today we are attempting to break a Guinness World Record under the heading Largest Practical Science Lesson. I repeat, Largest Practical Science Lesson. The existing record is 1,339 students created by Royal Society of Chemistry. A very warm welcome to all for this mega event. As per the guidelines, let me give an introduction. As per the guidelines of Guinness World Records, there should be 2 independent witnesses to certify the activities going on here. In addition to this, we have a specialist independent witness who is an expert in this subject. We are fortunate to have here Sri Dharmendra Kumar IPS, Special Commissioner and Director General of Police, Delhi, and Dr. Arup Kumar Misra, Director, Assam State Science, Technology and Environment Council as independent witnesses, and Dr. Professor Syed Akil Ahmad, former Vice Chancellor, Enopaya University and Professor of Chemistry, Mysore University, as a specialist independent witness. There are 40 eminent personalities acting as stewards. Each steward will be in charge of 50 students. They will be directly submitting the reports to the independent witnesses. The independent witnesses will also record the actual time of the lesson with the aid of a stopwatch accurate to 0.01 seconds. As all of you know, counting of the students was carried out by the pre-approved wristband method. The seating of the students in the venue is as per the pre-approved layout, and the lesson will be based on the pre-approved lesson plan. There will be 3 qualified and experienced instructors: Dr. Anita I, Associate Professor, Maharajas College, Ernakulam, India; Ms. Ammur Rosin Jose, Research Fellow, Cochin University of Science and Technology, Kochi, India; and Ms. Shalini Menon, Research Fellow, Cochin University of Science and Technology, Kochi, India. Ms. Shalini Menon will handle the lesson covering the theory, principle and applications of catalysis based on the pre-approved lesson plan. Two selected experiments, the Fenton's reaction and also the elephant toothpaste experiment, illustrating the effect of a catalyst, will be demonstrated by the other two instructors, and the students will do the experiment by themselves. While doing the experiment, students are expected to get an idea of good laboratory practice also. The event is coordinated by me, Professor K. Girish Kumar, and also by Dr. Arvind C. Ranade. Organization Vijnan Bharati India, and the responsible person is Sri A. Jayakumar, Secretary General of Vijnan Bharati. Title of the record is Largest Practical Science Lesson, and the reference number is 15091 0093558 LPSL. With this brief introduction, I invite the instructor to start the lesson. All the best, students. We are starting it. The instructor will come and do her duty. Thank you.
Here we begin the lesson. The lesson starts now. Namaste or Suprabhat, my dear friends. Hope you're having a great day. Are you? Yes. If not, don't worry, it's going to get really amazing the next few minutes. Today, we have gathered here to make history. Less than 1% of the world's population has been fortunate enough to be a part of the Guinness Book of World Records. And today, we are going to try and break into the privileged category. So friends, get ready to break some records and reach the top of the world. Before we move on, please keep in mind the wise words of Helen Keller when she said, "Alone, we can do so little, but together we can do so much." With that, we begin the lesson. In today's lesson, we are going to discuss about what a chemical reaction is, about catalysis, the different types of catalysts, catalytic promoters, catalytic poisons and optimum temperature, hydrogen peroxide and its significance, and about peroxide catalyzed by iodine. So let's see what a chemical reaction is. For a chemical reaction to take place, the reaction molecules must collide with each other, and the collision of these molecules provides kinetic energy to break the necessary bonds of the reaction molecules so as to form the new bonds of the products, right? And for a chemical reaction to take place, it is not just the kinetic energy that you require, you require something else, which is also called as the activation energy. Now what is activation energy? Let's see. Just like how your teachers and your parents give you a push from behind, asking you to sit and study, for a chemical reaction also you need to give a push to kickstart the reaction and to carry on the process spontaneously. Now that energy required to kickstart a chemical reaction is called as the activation energy. And higher the activation energy means that reaction requires more energy to kickstart than the reaction with lower activation energy. Now, coming to the topic catalysis. To know more about catalysis, we need to ask ourselves three important questions like what is a catalyst, how a catalyst works, and where catalysts are used in everyday life. These are three important questions in catalysis, like what must take part in the reaction, or we might as well not have it there at all. So coming to the next question, question number 2, which is how does a catalyst work? A catalyst works by providing an alternative pathway for the reaction, which has lower activation energy than the pathway without the catalyst, as you can see there. Now I can show you the energy diagram for the reaction with the catalyst and without the catalyst. The blue pathway is the energy profile for the reaction without the catalyst, whereas the red pathway is the energy profile for the reaction with the catalyst. And as you can see there, with the catalyst, you require lower activation energy than the one without the catalyst. And as a result of the action, there are catalysts used in everyday life. Most manufacturing processes are exothermic in nature due to economical reasons. And the heat given out is used to maintain the operating temperature of the reaction. Exothermic reactions, as we all know, cannot take place at high temperatures because the yields will be too low. So, in order to increase the rate of such exothermic reactions, what can we do? We will have to add catalysts. We cannot increase the temperature and increase the rate. Instead, we have to add a catalyst to increase the rate of such exothermic reactions. Now we see two important manufacturing processes that use catalysts, the Haber process and the contact process. The Haber process, which is used in the manufacturing of ammonia, used mainly in fertilizers, uses the catalyst iron, Fe. And to it we also add potassium oxide, which acts as a promoter to increase the efficiency of the iron catalyst. Coming to the contact process, which is used in the manufacturing of sulfuric acid, used mainly in fertilizers and detergents. Here, the catalyst used is vanadium thioxide, or what we call as vanadium pentoxide. Now, catalysts are also used in catalytic converters in vehicles. Now, what they do is, they remove the toxic exhaust gases by converting them into harmless products. Now, to recap, catalysts are substances which alter the rate of a chemical reaction without themselves being used up in the reaction. And how do they work? They work by lowering the activation energy. And catalysts are used in the Haber process, the contact process, and also in catalytic converters. Got it? So moving on to the next topic, the different types of catalysts. Catalysts can be classified on two bases, based on the phase and based on the rate of reaction. On the basis of phase, catalysts are classified as homogeneous and heterogeneous catalysts, and based on the rate of reaction, they are classified as positive and negative catalysts. Let's see in detail. To know about homogeneous and heterogeneous catalysts, you firstly have to know what is a phase. What is a phase? In a mixture of components, if you can see a distinct boundary between the two components, we say that those two components are in two different phases. But if they are miscible, we say that they are in a single phase, right? As you can see there on the figure, the first one is a liquid and a solid phase, and you can see a distinct boundary between them. So we say that those two components are said to be in two different phases, whereas the second one, it is in a single phase because they are miscible. Coming to the third case, you can see two liquids which are immiscible, meaning like water and oil. So they are said to be in two different phases or a single phase. They are said to be in two different phases, right? That's about phase. Now let's see what's homogeneous and heterogeneous catalysts. Homogeneous, for the word know, when the reactants and the catalysts are in the same phase, that process, that catalytic process is called as homogeneous catalysis. But when the reactants and the catalysts are in two different phases, we call it as heterogeneous catalysis. Now, heterogeneous catalysis is also called as contact or surface catalysis. Now, moving on to some of the examples of homogeneous and heterogeneous catalysis. Classic example of homogeneous catalysis is the decomposition of hydrogen peroxide by iodide, and that's the reaction we're going to perform today, right? Here, both hydrogen peroxide and potassium iodide catalysts are in the aqueous phase, and so that catalysis is called as homogeneous catalysis. Hydrogen is a protein with bromine catalyst. Here, it's two immiscible liquid phases. The catalyst in the aqueous phase, whereas the reactants and the products are in the non-aqueous phase. So that's really an example of heterogeneous catalysis. Oxygen catalysis is a biological catalyst which is enzyme. Most of the chemical reactions that take place in the human body and also in other living organisms are very high energy reactions that occur extremely slowly. So, to increase the rate of such reactions, we have to add, we can't add catalysts, but the enzymes work there. The example for that is in the absence of a catalyst, it takes several weeks to start. The step is the generation of chlorine, and for that step, you require a catalyst, that is copper chloride. Now, what are negative catalysts? Negative catalysts are also called as inhibitors. Do you know why? Because they decrease the rate of the reaction. Now, how do they work? They work by taking a longer pathway and increasing the activation energy, thereby decreasing the rate of the reaction. As you can see, that it takes a longer pathway, and therefore the activation energy is also increased. Here is an example for a negative catalyst. Phosphoric acid can act as a negative catalyst for the decomposition of hydrogen peroxide. And we all know that we are going to perform today's experiment. One of the experiments is a catalyst. So what do we do? We have to add negative catalysts. Here is the example. To decrease the ignition of petrol vapors, you add tetraethyl lead to petrol. So here, tetraethyl lead acts as a negative catalyst. And if we don't add this, what happens? The petrol vapors will ignite even earlier than expected, resulting in the wastage of fuel. So in order to improve the fuel efficiency that we're going to perform today, experiment number 1, which is catalytic discoloration of methylene blue by hydrogen peroxide, and the second experiment, the catalytic decomposition of hydrogen peroxide. In the first experiment, hydrogen peroxide, being a strong oxidizer, is going to oxidize methylene blue. But that reaction is a very slow process. The iodide potassium iodide as the catalyst here. And in this reaction, we also add some detergent solution and some color just to make the reaction more visible. Okay? Now in these two experiments, you can see something in common. What is that? Yes, hydrogen peroxide or H2O2. So let's get to know more about hydrogen peroxide. It ranks up there as one of the best household remedies. And it is one of the few miracle substances still available to the general public. It is highly safe, readily available and dirt cheap. And best of all, it works. Hydrogen peroxide can put extra oxygen into your blood. So if you can get oxygen into the blood cheaply and safely, maybe diseases like cancer which doesn't like oxygen, and also emphysema, AIDS and many other terrible diseases can be treated effectively. Now, intravenous hydrogen peroxide can rapidly relieve allergic reactions, influenza symptoms and acute viral infections. And because of all these medical advantages, yes, that's right, the mother's milk, especially for us, contains high concentrations of hydrogen peroxide. And the main function of mother's milk is to activate or stimulate the immune system in infants. And the fact that it contains a normally high concentration of hydrogen peroxide definitely makes sense. Hydrogen peroxide, strong oxidizer, a bleaching agent, and also a disinfectant. And when present in the concentrated form, it is used as a propellant in rockets. Now, you can see some of the reactions of hydrogen peroxide. Hydrogen peroxide undergoes decomposition reaction, Law's reaction, organic reaction, and also, as you can see there, hydrogen peroxide decomposes to form water molecules and also oxygen. But like I said before, this process is a very slow process. So in order to increase the rate of this reaction, what can we do? We can add a catalyst to it. Now, which is the discoloration of methylene blue by hydrogen peroxide. This reaction is also called as Fenton's reaction. It was discovered by Henry John Postman Fenton in the 1890s, and the classical Fenton's reagent is hydrogen peroxide combined with an iron catalyst. Fenton was not one. They postulated that the successful reaction generates a highly reactive hydroxyl radical, the OH radical. As you can see there in the diagram, hydrogen peroxide in the presence of iron catalyst produces a powerful oxidizer, hydroxyl radical. And Fenton's reagent has been widely used. Like I said before, hydrogen peroxide, even strong oxidizer, can oxidize methylene blue. But that reaction is going to be very slow. So we add a catalyst to it. The catalyst added is Fe2+. And hydrogen peroxide oxidizes methylene blue at a faster rate in the presence of Fe2+, resulting in the discoloration of. Now, here are some of the applications of Fenton's chemistry. It is widely used to treat a variety of complex industrial wastes. It's used in the soil and the groundwater remediation, heavy metal contaminated wastewater, to destroy organic resins and radioactive contaminated sludge, in the COD and VOD reduction, and also for odor control. Now coming to the second experiment, which is the catalytic decomposition of hydrogen, you are going to observe a column of foam emerging from a measuring jar that resembles a huge stream of paste. So that's the reason why this experiment is also called as the elephant toothpaste experiment. Now what is this experiment actually? What is the chemistry behind it? This is also a decomposed catalyst added is potassium iodide. It's the iodide ion from potassium iodide that acts as the catalyst here. It speeds up the reaction without itself being consumed in the reaction. Now here is the mechanism. The iodide ion changes the add disturbing solution to it, and because of the now I think we're done with the theory. So shall we move on to the performance of the experiments, friends? Now I think it's very time to go and perform the experiment. And before that, wait, you still have time. All of you, get ready, get connected, work together and be prepared to experience the magic of chemistry. And now what I want you to do is watch the demo. You will perform, and I'll tell you when to perform. So now you're going to watch them. We have the instructors here and they're going to perform the first experiment for you. Have it here. Experiment number 1. The discoloration of methylene blue by hydrogen peroxide. The chemicals required are methylene blue solution, hydrogen peroxide, H2O2 present in the small. Then we have ferrous sulfate salts. And we also have a beaker to perform the experiment. Now what you have to remember is the first set of chemicals will have a green label on it. We have a green label on it. So shall we see how these chemicals were prepared? We've taken 10 ml of 30% hydrogen peroxide and H2O2, and methylene blue solution was prepared by adding 1 drop of methylene blue reagent in about 20 ml of water, and we have taken 50 milligrams of ferrous sulfate salt. So, ready to see the experiment? So shall we move on to the procedure? What do you think will be the first procedure? The washing. The washing of the apparatus, which is a good laboratory practice. Washing of the apparatus. So, the instructors are going to wash the beaker with the water in the wash bottle. Just work to make sure the beaker is clean and empty the contents. Step 1. Take the methylene blue solution into the beaker. You can see that now the methylene blue solution is in the beaker. Shall we move on to the next step? Step 2. Add the given H2O2. You can see the instructors have added hydrogen peroxide to methylene blue solution. Is there a reaction there? Actually, there is a reaction there, but the process is very slow. It's just that it's not visible to us. So what do we do to increase the rate of the reaction? We are going to add the catalyst, which is step 3. Now you are going to observe a rapid color change. Why is it? It's because of the presence of the iron catalyst. It increases the rate of the reaction, and hydrogen peroxide oxidizes methylene blue at a faster rate in the presence of the catalyst, Fe2+. So now, are we done with the reaction? No. We have one more step there. What is that? The cleaning part. We're going to empty the contents of the beaker into the buckets, which is there next to them, and wash the beaker. Now the beaker is clean and we are done with the demo of the first experiment. So what they're going to do is keep the first set of chemicals aside. Now, what do you want to perform? Now it's your turn. Friends, are you all ready? Yes. Ready? Shall we start?
Yes, miss.
Okay, students, get ready with your first set of chemicals, which contains a green label. Please pay attention. Your label. I'm going to say the chemicals. You have methylene blue solution. Can I say methylene blue solution? Yes. Then you have hydrogen peroxide with the green label. H2O2 with the green label. Then we have ferrous sulfate salts. Can I say something? Okay, we have the ferrous sulfate salts. And what else do we need? We need the beaker to perform the experiment. So, there's the beaker. Yes, I can see that. Now, students, you've been sitting for quite a long time. So, can you all stand up? We're going to perform the experiment. We're not going to sit down. Stand up and be active. You are going to do the first experiment now. So be ready. We're moving. Wash the beaker. Swirl it around and make sure it's clean. With the water in the bucket which is there next to your table. Are you all that? Ready? Yes. Okay, shall we go on to the procedure? Methylene blue solution into the beaker. All students take the methylene blue solution into. Can I see there now? Can I see the methylene? Okay, all of you have taken the methylene blue solution into the beaker? So shall we move on to the next step? Your step 2. Add the given hydrogen peroxide, that is H2O2 with the green label, to this methylene blue solution. Add H2O2 to this methylene blue solution. Please, one with the green label. I can see hands out there. Now swirl well, see if there is any change. But is there a reaction taking place there? Yes, there is a reaction taking place there, but you are not. And what's the catalyst? Yes. So moving on to step 3. Add the given ferrous sulfate salt to this solution and swirl it. And swirl well. Yes, I want to see the color change. Can you see the color change?
Yes.
Is there a rapid color change?
Yes.
Or is it still the blue color that you're seeing? No. We have observed a rapid color change. Why is it? It's because of the presence of Fe2+, which acts as a catalyst here. What does it do? It increases the rate of the reaction. Which reaction? 1, QT2. What is that? The washing part. Yes, the good laboratory practice, you should never forget this. Empty the contents of the beaker to the bucket, which is there next to you. I hope all of you know that this is a good laboratory practice which all of you must follow when you enter the lab. Now wash the beaker with the water in the wash bottle. And once again, you can empty the contents into the bucket which is there next to your table. But before that, you have one more duty to do. You have the first experiment, just and also write down the conclusion of the first. Now you can sit down and write.
You can sit down now.
Remember, you must leave space. You write down your name, your class, your school, your observation for experiment number 1. But note, you must leave space to write down the conclusion for experiment number 2 also.
बारिश हो रही है।
So are you all ready? Once again I repeat, make sure your name, your class, conclusion for experiment number 1, leaving space for experiment number 2. So, you ready? Shall we move on? Sure? Can I hear a no from somewhere? No? All are ready? So we moving on. Perform the experiment now. You are only going to watch the instructors perform the demo. Now, experiment number 2. The measuring jar with the water and the wash bottle. What can we do now? The fourth step, which is the addition of potassium. Yes, now there is no immediate reaction, and so you're going to add to this. And there it goes. You can see an immediate reaction. You can see the foam coming out just like the emerging sun in India. Right? You can see the sky color, Tiranga of our national flag. The Indian national flag is a representation of the rich Vedic heritage of India, and there you see the Tiranga or the tricolor of our national flag. So, what's next? No. I told you this experiment is exothermic, so it's going to be slightly hot. And for you all to watch this, we're going to keep it here, on it. Pay attention. Get ready with your second set of chemicals for experiment number 2, having the white label on it. Hydrogen peroxide in the big bottle. Detergent solution. Food color only label, you know why? And potassium iodide solution. And the measuring jar to perform the experiment. So are you all ready with your second set of chemicals? So shall we move on? You ready? Okay. So moving on to the first step, the cleaning part, the good laboratory practice. You may please wash the measuring jar with the water in the wash bottle. Swirl it around to make sure it is clean and empty the contents into the bucket which is there. So you are ready with the measuring jar? Shall we move on to the procedure? Ready to experience the Tiranga? Okay. Moving on to your first step. Pour the given H2O2 solution into the measuring jar. Your first step. Pour hydrogen peroxide solution into the measuring jar. Now you can see hydrogen peroxide solution in the measuring jar. And with that we move on to your second step. Add the detergent solution to it and swirl it around. Add the detergent solution to hydrogen peroxide and swirl it around there. Any change? You observe any change? No change. Swirl it around. Moving on to the third step. The step number 3. Add the food color if it is there on your table. Others can just watch your friends pouring the food color to the measuring jar. If you have food color on your table, please pour it into the measuring jar. Now there's saffron on one side, there's white in the middle, and green on the other side. You can look around. That was. Is there an immediate reaction now? Hydrogen peroxide plus detergent plus color? No. So you are going to add the catalyst, which is potassium iodide. Step number 4, addition of potassium iodide. Observe the tiranga of the tricolor of our national flag. Your step number 4, add potassium iodide solution to the measuring jar. Hydrogen peroxide plus detergent plus color plus potassium iodide is an immediate reaction. Emerging signs of India. The song comes out presenting the emerging signs of India, the tiranga of our national flag. Friends, you have completed that reaction. Great. So now, since it is an exothermic reaction, please sit down. All of you please sit down. Read it and your conclusion for the second experiment. Students, write down your observation and conclusions for your second experiment. make sure your name, your class, your school is all there. Your observations for experiment number 1 is there. Your observation for experiment number 2 is there on the paper. And your conclusions about the 2 experiments. Now I hope you all have with you a completely fresh student report having your name, your class, your school, your observations for experiment number 1 and 2 and your conclusions next. Before that, I want all of you to hand over the reports to your teachers, and the teachers are going to hand over the reports to the stewards. I request all the teachers, please collect the student reports from the students and hand it over to the stewards. So I hope all the teachers have collected the student report. I request you all to please hand it over to the steward. Please well, and I see the content of the lesson done with the bucket and the next. Students, please remain silent. We're coming to the end of it. I request most recomposition violence oxide with IISF. In both the experiments, it's the catalyst that brings in the magic. So, the catalyst is like alphabet magic that can make reaction all in its own words. A catalyst is called a creative reactor, inspired by younger generations to have a voice in the new power and both for more and more students to take up
सुन भैया यार ये कर लिया था ना आपने
the
अरे क्या है